This is our video for Unit 6, Day 4. So we got two different sets of notes that we're going to cover in this video. Yesterday we talked about finding area and perimeter for polygons. We're going to start off with today is doing the same thing with circles. So circles do have area, but they don't have perimeter. It's something different. It's called circumference. That's what we're going to be talking about in the first half. So first thing is talk about what a circle is. So there's a very strict mathematical definition of what a circle is. Is that it's a set of all points, so a collection of every point that are the same distance away from a given point. So if you pick a point and you pick a distance, every point that's that same distance away from the first point, that forms a circle. So the distance they are away, that's called the radius. And the given point we're measuring that distance from is called the center of the circle. So if we look at our picture down here, the circle, this would be our center. We go out to the edge of the circle, that's our radius. So every point on the edge of the circle would be that same distance away from the center. So that's where that definition comes from. Next thing is we have the distance all the way across the circle. So the distance from one side of the circle to the other side going through the center is called the diameter. And this is equal to 2 times the radius. So we take circle, we go from one side of the circle through the center and all the way to the other side of the circle. This would be a diameter. So distance around the outside of the circle is called the circumference. So with polygons, that's called the perimeter, but with circles, that's called the circumference. So a very special property of circles, it's not true for any other type of shape, is that the ratio of the circumference to its diameter is always the same. So no matter what size the circle is, that ratio, that fraction you take with the circumference and diameter, it's always going to be the same. That ratio is called pi. Right, in pi we use this symbol for pi. So all these problems involve circles. A lot of times we see pi in there. Anytime we're using area or circumference, we're going to see pi show up in our answer. So when we're doing these problems, you don't need to actually multiply by pi. So you know that pi is about 3.14, and it's an infinite repeating decimal, not non-repeating decimal, just keeps going. But you don't need to actually multiply by it, just leave the pi symbol in your final answer. So again, what pi actually is it's the ratio of the circumference of a circle to its diameter. So if we actually took that ratio and solved it out for circumference, that's where we get one of our formulas from finding circumference is pi times diameter. And since we know that diameter is actually just 2 radius, we can also say circumference is 2 pi times radius. So area has a different formula. For the area of a circle, we use this formula, pi r squared. So we square the radius. So it's not like circumference where we can either use radius or diameter. We have to use radius. We square that and multiply by pi. So here we're going to do two examples so you can see how this works with actual circles. So we need to find circumference and area. So here, 5 is my radius. It's not diameter, it's the radius. So to find the circumference, I'm going to multiply 2 times 5 times pi. So that would just be 10 pi. And again, we're going to leave that pi symbol in our answer. So this is our final answer. 10 pi is the circumference. Area is pi r squared. So that's going to be pi times 5 squared. So 5 squared is 25. So our final answer is going to be 25 pi. And again, leave it just like that with the pi symbol. Don't need to multiply it out by anything, just leave the pi symbol in the answer. It's perfectly fine. So that's an example where we start with the radius. Example on the right, we're not starting with the radius, we're actually starting with the diameter. We start with the diameter, it makes finding the circumference very easy. We just take that diameter and put a pi symbol in front of it. To find the area, though, we have to break this down. So diameter is 2 times the radius. So if the diameter is 18, our radius is 9. You have to use the radius in our area formula, pi r squared. It's going to be pi times 9 squared. 9 squared is 81, so this would be 81 pi. There's an example of each of different kinds of problems with the circles. On the back of this sheet, you'll see there's a bunch of different practice problems for you to do. Some of them give you the diameter, some of them give you the radius. But for each one, you have to find the area and the circumference to make sure you're doing both parts of this problem and make sure you leave pi in your final answer. So you can either pause the video here and work through the practice, or you can go through the notes and do the practice at the end of both sections. But we do have one more set of notes to do. It's on 3D figures, volume, and surface area. So polygons and circles are two-dimensional figures. We're going to work with here. This set of notes is three-dimensional figures. So three-dimensional figures have three different dimensions: length, width, and height. So not just length and width, but um, length, width, and depth. So they have three different dimensions. So polygons only have length and width. So here we have some different concepts that figure into the 3D figure. So the amount of space inside of a three-dimensional figure is called the volume. So this is kind of like the three-dimensional version of area is the volume. The amount of space inside a 3D figure. It's also saying that same thing as saying it's the amount of space that a 3D figure occupies or contains. The next idea is the area around the outside of a 3D figure. So 3D figure, if we took, basically it's like if we unwrapped it, what would the area of all that be? That's called the surface area. So just like with the polygons that we worked with yesterday, each 3D figure has its own unique formula for finding volume. And there's four different 3D shapes we're going to go through. To find the surface area, all you have to do is add the area. Right, the area is made of either polygons or circles of each face. So we're going to go through four types of three-dimensional figures. First one is called a prism. So a prism is a three-dimensional figure that has two parallel polygon faces. And these are called the bases. So they could be any type um, of polygon. It could be rectangle, it could be a square, it could even be a triangle, trapezoid, parallelogram, whichever. But you name a prism according to the shape of its base. So in the picture below, right here, we see that the base is a rectangle. So we would call this a rectangular prism. So to find the volume for a prism, all we do is we take the area for the base and multiply it by the height. So if it's a rectangle, like this one, it would be length times width times height. If it was a triangle, we'd use 1/2 length times width times height. So it's just whatever you can do to find this area for the base, and then multiply this area by the height. So here'd be an example. On the right hand side, we have another rectangular prism, has a length of 5, width of 3, height of 4. So we would just multiply 5 times 3 times 4. 5 times 3 is 15, times 4, 60. So again, depending on the shape of the bases, you might have to use a different formula to find the area for the base, but you're always going to find the area for the base multiplied by the height. So our second 3D shape is called cylinder. It's very similar to a prism. It has a different type of base. So a cylinder, another three-dimensional shape. That has two parallel circular bases. So instead of two parallel polygon bases like the prism, it has two parallel circular bases. Alright, so that's our only difference, is that the bases are circles instead of polygons. So our volume formula, look at this, is exactly the same as it was for prism. Area of the base times the height. But since the base is a circle, area for the base would be pi r squared. We could also say the volume for prism would be pi r squared h. So pi r squared, area for the base, times the height. Alright, so it's the same idea as we find the area for this circle up here, and then multiply it by the height. So that's what we're going to be doing on this one. We have a cylinder with radius of 3, height of 10. So first thing is we find the area for the top, which would be pi r squared. It's like we did earlier in this video, so if the radius is 3, square that would be 9 times pi. Then we take 9 pi, multiply it by 10, and we get 90 pi. And And again, just like with the other circle problems, we're going to leave the pi in the answer, not going to multiply it out or change it. Alright, so you got two more 3D figures here. Next one is a pyramid. So the pyramid is a 3D figure. Three-dimensional figure that has one polygon base, and all the other faces are triangles. So all those triangle faces are going to meet at a common point, and that common point is called the vertex of the pyramid. So when you use when you find the volume of a pyramid, you need to use the perpendicular height, just like we did with the triangles and the parallelograms and the trapezoid yesterday. You have to use the perpendicular height from the top of the pyramid, from that vertex, all the way down to the base. Right, but it has to be perpendicular. That's where we see this right here, drops straight down. It's perpendicular, it meets the base at that 90-degree angle. So our volume formula for a pyramid is the same as the volume for a prism. We just multiply by 1/3 is the only extra thing on there. So if we look at our example problem over here to the right, it's the same thing. It's 1/3 area of the base times the height. So here we find the area of the base, 3 by 4. So this area down here is 12. So I'd multiply 1/3 times 12 times 8. So 1/3 times 12 would be 4, and 4 times 8 is 32. Last one of our three-dimensional figures is called a cone. So a cone is another three-dimensional figure. And this one has one circular base. It comes together at a common point. So just like with the pyramid, it's pointed. The difference is the base here is a circle. So it's the same as the difference between the prism and the cylinder is the same difference between the pyramid and the cone. Again, we look at the volume formula, it's the exact same right now as it is for the pyramid, but since the base is a circle, we already know that area for the base formula is going to be pi r squared. So we can add all these pieces into the formulas. 1/3 pi r squared times height would be our volume formula. So again, here's our example. We notice again that we're using perpendicular height. On the cone, just like we do with the pyramid. So again, we need to make sure we're finding the area for the base first. So my base is now a circle with radius of 3, which makes the area for the base 9 pi. So pi r squared. Then we're going to multiply that by the height and by 1/3. So volume would be 1/3 9 times 5. So 1/3 of 9 would be 3, and 3 times 5 would be 15. So we have 15 pi as our volume. So last thing just to point out is how similar each of these things are. So the cylinder we saw was just like a prism with a circular base, and a cone is just like a pyramid with a circular base. So a lot of similarities between these. So your homework for tonight, you'll be working with some of these shapes and making sure you're comfortable with naming them, classifying what kind of 3D figure they are, and also finding the volume.